Basic Geometry Review. In this self-quiz, we will cover about 50 different geometry problems. If you already know it, skip the slider bar at the bottom and skip it. Just go to the next one. Okay, this is the way this works. Click on the stop sign here, try to solve the problem. Once you have it worked out, click on the go sign and I'll show you it worked out. Click on the stop sign. Alright, let's see how you did. Well, it says in the diagram, line segment DB, that would be line segment DB right here, bisects angle ADC. Now we know D is the vertex because it's in the middle of these three letters. ADC, it says this is our bisector. Bisecting means to cut it in half. If the measure of angle 1, this angle right here, is equal to 4x plus 7, and the measure of angle 2 is equal to 6x minus 13, what is the measure of ABD? In other words, what is the measure of this angle right here, angle 1? Well, it turns out that it's a bisector, so that means that 1 is equal to 2. So you can set them equal to each other and then solve for x. 4x plus 7 equals 6x minus 13. Solving grouping like terms, so we take 4x off of each side, so we wind up with 7 equals 2x minus 13, and you certainly could have done it a number of different ways, but I did it with 7 now equals 2x minus 13, add 13 to each side, and I wind up with 20 equals 2x, divide both sides by 2, and I get x equals 10. I would then come back along and plug that in. The correct answer is not x equals 10. I had to find x equals 10 so that I could plug that back in and say 4 times 10 plus 7 is equal to 47. Wanting to check to see if I was right, I can come in and say 6 times 10 is 60 minus 13 is also 47. So the correct answer is not 10. The correct answer is 47. Click on the stop sign, see if you can answer the question. All right, let's see how you did. It's asking you what is the measure of angle VXR. So VX, X being my vertex, and R. So what's this angle right here? Well, we take a look at this and we can say, well, we know that all four-sided quadrilaterals, and quadrilaterals are all four-sided, total to 360 degrees. Or we could say we know that all triangles are 180 degrees internally. So we have two ways we could have solved this. The harder way, or the easier way. And so let's see. If I know that this is going to be 72, and I know that this is 145. This angle right here is 145. And then I look at it and I know that this angle right here is 90. And I subtract 23 from 90, I get 67. So that means 72 plus 145 plus 67 plus some amount is equal to 360. That's one way to solve this problem, and you might have come up with 76 as the answer. Or another way to have done this would have been to recognize that this angle right here, 72 degrees, and this angle right here were supplementary, meaning that they total 180. So I'm able to then calculate that this is 37 degrees. Since this is a larger right triangle, if this is 37 degrees, then I could calculate through that this is 53 degrees, find out that this is 104 degrees, and 104 plus 76 are supplementary, which means that I have independently verified that this angle right here, angle VXR, is 76 degrees. All right, consider the statement. If a triangle Consider the statement. In a triangle, the measure of an exterior angle is always greater than the measure of the adjacent interior angle. Well, first of all, let's take a look at what that means. Drawn a little example for you here. This is an interior angle, and this is an exterior angle. This is an interior angle here, and this is an exterior angle here. So it's telling you that this statement says that all exterior angles are larger than interior angles. So it's asking you what's a counterexample. Well, the definition of a counterexample is an example that refutes or disproves a hypothesis, proposition, or theorem. So now, which one of these four disprove or are a counterexample of the statement above? Click on the stop sign. Okay, Let's see how you did. Well, let's look at a right triangle here. If this is our interior angle and this is our exterior angle, they are equal in size. Therefore, this is a counterexample of the statement above. An obtuse triangle would be as well, but that wasn't one of your answer options. Which of the following formulas may be used to find n, the number of sides of a convex polygon, the sum of whose interior angles measure is s? So here we have a bunch of different equations. So which one would prove the number of sides, or you could use to find the number of sides of a convex polygon? Click on the stop sign. All right, let's see how you did. Well, it turns out that the correct answer on this one was n equals s divided by 180 plus 2. Let's work an example. For example, you know that the number of sides on a triangle is 3. And so you know that the number of angles, if you total the number of angles, the number of degrees, excuse me, in a triangle, it's a 180. So 180 over 180 is 180 over 180, which is the same thing as 1. 1 plus 2 is 3, and so this checks. But we could also check to see if maybe that was an anomaly, meaning that it only happens in that one case. We know that the internal degrees of all squares happen to be that there are 4, and they total 360 degrees. So if we replace this number with 4 and we stick 360 here, 360 divided by 180 is the same thing as 2. 2 plus 2 equals 4. So therefore the correct answer is n equals s divided by 180 plus 2. See if you can click on the stop sign and solve for x. All right, let's see how you did. Well, we take a look at this, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 x's equal a total of 360 degrees, because if we start anywhere here and go all the way around, it's 360 degrees. So 15x equals 360 degrees. Divide both sides by 15, and we get x equals 24. If you wanted to check that, you could. All right, click on the stop sign, see if you can solve this problem. All right, let's see how you did. The base of an isosceles triangle is cut into 2 equal pieces, this being the base, and it's cut into 2 equal pieces by the altitude from the vertex. In other words, this right here, which means that this is a 90-degree angle. And they want to know how long is this line and how long is this line right here. Well, if this was 10, as we are told in writing above, and the altitude here is 12, this cut in half would be 5, this would be 12. We apply the Pythagorean theorem, and so 5 can be rewritten as the square root of 25, and 12 can be rewritten as the square root of 144. If we add the number 25 to the number 144, we get the number 169. If we put that under a square root sign and take the square root of that, we would find out that the correct answer is 13. If this is 13 and it is an isosceles triangle, this too will be 13 here. All right, click on the stop sign, read the problem, see how you do. Okay, let's see how you did. Well, the main thing that we're dealing with here is an isosceles triangle, and we are told that's an isosceles right triangle. We are told that this is 800 and this is 800 approximately, so they want to know what's this distance right here. And if we were dealing with this being completely flat, then this would work in Euclidean geometry. And unfortunately, you and I both know that this is on a sphere, so our answer is going to be only approximate, which it asks you here, approximately what is the distance from Tallahassee to Lincoln? Well, writing 800 under the square root sign and writing 800 under the square root sign, adding those numbers together and then taking the square root of that total would give us 1,131.3 miles. Click on the stop sign, try to answer the question. All right, let's see how you did. Well, this is already in the slope-intercept form of y equals mx plus b, and so we know that m is our slope. So if this slope is 3 and this slope is 3, they have different y-intercepts, and they are parallel lines, because all lines that have the same slope are parallel lines if they're not laying on top of each other. All right, click on the stop sign, see if you can solve this. Okay, let's see how you did. Well, our slope in this case, we're in the slope-intercept form. Our slope here is -2, so I've sketched in a -2, and our slope here is a +1. And if we take a look at this, our sign changed, and we flipped over the fraction of 2 over 1, and we got 1/2. So that means that these two lines are perpendicular to each other. Click on the stop sign, see how you do. All right, first thing I did was I drew a picture so that I could visualize this, and the picture that I drew, while not perfect, let me see that I was dealing with a circle, and I had some diameter that passed from -4 to +1 to +2, -7. And I recognized that that is the hypotenuse of a right triangle. The difference in the x direction is if I start the displacement. If I start at -4 and I go to +2, that is a total of 6 units in the displacement. And if I start at 1 and I go to -7, that is a total of 8 units displacement. So I have now a right triangle with one leg being 6, one leg being 8. 6 can be rewritten under the square root sign of 36, and 8 can be rewritten as the square root of 64. If I add the number 36 to the number 64, I get 100. If I put that under the square root sign, I get the square root of 100 is exactly 10. Or perhaps you recognize that this is a dilated right triangle of the 3, 4, 5 by a factor of 2. So instead of this being 3 here, it was 6. And instead of this being 4 here, it was 8. And instead of this being 5 here, it was 10, being dilated by a factor of 2. See how you do on this? Click on the stop sign. All right, I drew a picture. Looks like this. It says circle O. This midpoint right here, the center of the circle, would be point O, and it tells me that it is located at x equals 1 and y equals -2. So this point right here is 1, -2, and this point right here is -3, -4, which means that it's really nothing more than the hypotenuse of a right triangle that has a height of 2 and a displacement in the x direction of 4. I can rewrite the number 2 under the square root sign as being the square root of 4, and I can rewrite 4 under the square root sign being 16. If I add the number 4, I'm not adding the square roots. If I add the number 4 to the number 16, I get the number 20. If I put that under a square root sign, that means that this length right here is exactly the square root of 20. Now, your answer options, if you're taking one of those multiple choice types of horrid tests, then your answer could be either square root 20, your answer could be 2 square root 5, or you could figure out what the decimal equivalent of that, which you know would be more than 4 and less than 5. It would be somewhere in the neighborhood of 4.5, 4.6. All right, click on the stop sign, see if you can solve for the area of the trapezoid. All right, a couple of methods you could use to solve this. The one that I use is I just broke it into two shapes, a rectangle and a triangle, and I had to use the information given here, as this being 15 and this being 12, to find out that this length here was 9. If this length here is 9 and I subtract 9 from 25, then this length here has to be 16. Either method that you use, the formula or breaking it up into two different parts, either method you are going to have to calculate that this length here was 16. So if I multiply 12 times 16, I get 192 units squared, and if I multiply 12 times 9 divided by 2, I get 54 units squared here, and I add those two together, I get 246 units squared, and if I had plugged it into the trapezoid formula, I would get base 1 plus base 2, the two parallel lines, divided by 2, thereby finding the average of these two, and multiplying that times the height here, I would have gotten the same answer. And so would you. All right, click on the stop sign and see if you can figure out what the diameter of the circle is. Okay, let's see how you did. Well, turns out that we know that pi times the radius squared, how you find the area of a circle, is exactly equal to 78.54 centimeters squared. Well, if I now look at this and say, well, you know what, let's divide both sides of this equation by pi, I get r squared is equal to 78.54 divided by 3.14, correct to 2 decimal places. Well, that comes out exceedingly close to 25, so I now know that r squared is equal to 25, and so r, if I take the square root of r squared, I just get r, and if I take the square root of 25, I just get 5. My radius is 5, but the original question, the tricky part of something like this is the original question was what's the diameter? If the radius is 5, the diameter has to be 10, because the diameter is always twice the radius. Click on the stop sign, see if you can solve the problem. Okay, let's see how you did. Works like this. We have a large rectangle, and we want to know what the total area of that is, less we're going to subtract the smaller rectangle. And if we did that, we would find that the large rectangle minus the small rectangle would give us 288 meters squared. Okay, click on the stop sign, see if you can solve. All right, here we have a right triangle. We know the length of the hypotenuse and we know the length of one of the legs. And so if we wanted to find out what x was, there are multiple ways for finding out what x is, but that's not what the question is. The question is they're asking you which one of these would you use to solve this ACB triangle. And it turns out that the correct answer here, in this case, would be 15 squared minus 8 squared, and take the square root of that. Find the value of x to the nearest meter. Click on the stop sign. All right, what we have here is just a right triangle, and if this distance right here is just one of the legs of the right triangle, and this distance here is one of the legs of the right triangle, and this is the hypotenuse of the right triangle. And so if you had come up with the answer being the square root of 4,896, which simplifies then down to, or goes to the decimal of 69.97 meters, that would be wrong. The question asks you, what is x to the nearest meter? And the nearest meter is 70 meters. All right, click on the stop sign, see if you can solve for x. Okay, you're being asked to find x in the length of feet rather than in meters, and you're given the information in meters. So you could very easily use the Pythagorean theorem to find out that the length of x in meters was exactly 89.44 meters, but now they want you to convert that into feet. So if I take the number of meters, well, first of all, you already know that a meter is a little bit more than a yard, and a yard is 3 feet, so you know that you're going to be looking for an answer somewhere in the neighborhood of 270, simply because 3 times 9, 90, is going to be 270. So we take a look at 100 centimeters is the length of a meter. We're going to divide that by the total number of centimeters per inch, which gives us that there are 39.37 centimeters to the, inches to the meter. If we divide that by 12, we come up with 3.28 feet per meter. And crunch those through, so we're going to multiply 89.44 meters times the number of feet per meter, and we get 293.3. But the question says, if x represents the length of the wire to the nearest foot, what is the value of x? And so to the nearest foot would be 293 feet. All right, see if you can find the surface area of the box. Click on the stop sign. All right, you might recognize that the box is nothing more than 6 different rectangles, and a rectangle is just nothing more than length times width. So if we have here, if this is 4 and this is 5, then this area right here becomes 20, and we have an identical one over here that's 20. And the top of this thing is nothing more than a rectangle that is 4 centimeters by 9 centimeters, and that happens to be 36 centimeters squared. So we have 36 centimeters squared for the top and 36 centimeters squared for the bottom. Now, the back is 9 times 5, which is 45 centimeters squared, and the front is 45 centimeters squared. Put all that information together, and you get 202 centimeters squared. All right, find the surface area of the figure and include all sides. Well, I'm not real happy about this. The drawing doesn't show you very well that it's a three-dimensional figure, and the question doesn't either. So I have stuck in another drawing for you here that might help you. Click on the stop sign and find the total surface area of this triangular prism. Okay, let's see how you did. Well, if you came up with 72 centimeters squared, you're doing it right. This surface right here is nothing more than 5 times 4, and so that's 20 centimeters. The backside that you can't see here is 15 times 3, so that's 15 centimeters, 5 times 3, so that's 15 centimeters squared. The bottom of this would be 5 centimeters by 5 centimeters, or 25 centimeters squared. And then this triangle right here, this leg is 3 centimeters, that leg is 4 centimeters. 4 times 3 divided by 2 is 6 centimeters squared, and there's an additional one on the other side. Add all those together, and you get 72 centimeters squared. Find to the nearest square centimeter the surface area of this figure. Click on the stop sign. Okay, let's see how you did. Well, we have to calculate what is the area of this circle, which is nothing more than pi times the radius squared, and we have to calculate this circle right here, which is pi times the radius squared, and we come up with this being 78.5 centimeters squared. So we have two circles here at 78.5 centimeters squared, and then we have the lateral surface area, which is nothing more than the perimeter of this circle times the height. And the perimeter of a circle is nothing more than the diameter times pi, which means that this perimeter right here is nothing more than 31.4 times 30 centimeters. Add all that together, and you get 1,099 centimeters squared. All right, state the congruency relationship for these two triangles. Click on the stop sign. Right? Perhaps you recognize that it is side, side, side. These two, this line right here, FE, is the hypotenuse. If these are right triangles, is a common line between the two. They share that, so it is the same length. So this line here and this line here are the same length. This line and this line are the same length, and this right here is the same for both. So it is side, side, side. Approximate x to the nearest tenth. It's a really bad drawing, by the way. Pay attention to the numbers and not the drawing. Click on the stop sign. All right, let's see how you did. Well, if this is a 30, 60, 90 triangle, we know that the side opposite of the 30 is a length of x, and we know that the hypotenuse is the length of 2x. And we know that this opposite the 60 degrees here is x square root 3. So if the hypotenuse is 16, then that means that we are dealing with this length right here being 8, and this length right here being 8 times the square root of 3, which becomes 13.856, correct to 3 decimal places. But the question says to the nearest tenth, and the nearest tenth is 13.9 units. So it is 13.9 units long. All right, given the following triangle, find sine. Click on the stop sign. All right, let's see how you did. It works like this. Sine is always the opposite side divided by the hypotenuse. And this triangle happens to be rotated around a little bit, but that doesn't change that this side 4 is opposite from the angle theta about which we're speaking, and our hypotenuse is 5. So sine of theta is 4 over 5, or 0.8 in decimal form. If the length of a rectangle is tripled, what will be its effect on its area? Click on the stop sign. All right, well, let's take a look. What I did was I drew a picture. And it says if the length being singular in this case, and using the singular linking verb is, says if the length is tripled. So if I had something that was 1 by 2, I just drew a random rectangle, 1 by 2. If I triple its length to 6, 2 going to 6, then I went from 2 square units to 6 square units. And if I tripled my length in the other direction, and 2 to 3 instead of 2 to 1, in other words, the 1 becomes a 3, I'm up at 6 square units. So if the length of the rectangle is tripled, the area of it will also be tripled. The tricky part about this one was that you might have been anticipating that if it had said the lengths of the rectangle are tripled, well, then it would have gone up by a factor of 9 and not 3. Here you have a rectangle. Read the problem, click on the stop sign, come back, see how you did. All right, here's the way I handled it. I drew just a random little rectangle here. It happened to be a square, but a square is a rectangle. And I gave it dimensions. I called it 1 by 1. They said that it had r units squared. Well, if I triple one of the dimensions and quadruple, which means times 4, the other dimension, I now have, instead of a rectangle that is 1 unit squared, I have one that is 12 units squared. I don't know what r equals, but I do know that the new rectangle is r times 12 or 12 times r. In Euclidean geometry, which formula is used to find the distance between 2 points? Well, it's actually an equation. So which one of these would you use to find the distance between 2 points? Click on the stop sign. It turns out that this is the distance formula, and you use it for finding the distance on the Cartesian coordinate system. The shortest path between 2 points on the surface of a sphere is called an arc of a great circle. The arc of a great circle is as if a plane were passing through 3 points on the sphere, the very center of the sphere and the 2 points on the sphere. So in other words, to put this into context, if you were in Chicago, Illinois, and you wanted to fly to Moscow, you wouldn't fly east or west, you'd fly north, because the shortest distance for you to get to Moscow from Chicago would pretty much be to fly over the North Pole. That is called a great circle. Click on the stop sign, see if you can answer the question. All right, what's going on here? Well, we're with a compass, we're developing a perpendicular bisector. This dashed line segment right here exactly cuts this line in half, and it is also perpendicular to the line. So it is a perpendicular bisector, construction done with a compass and a straight edge. See if you can solve the problem. All right. Angle Q, or sometimes called angle RQT, is 40 degrees because the internal angles of all triangles in the known universe sum to 180. All right, click on the stop sign. All right, let's see how you did. Well, it says that if we rotated this counterclockwise, now this would be a counterclockwise rotation because that's the opposite way that the normal analog clock runs. And so to rotate that 180 degrees, this isn't even a rotation of it here. This is either no rotation or a 360 degree rotation. This rotation right here is the correct answer. It is as if you have rotated it 180 degrees counterclockwise. But even if you rotated it clockwise, it would still look like this with 180 degrees. And this one right here is a, let's see, that's not even a rotation either. So, all right. Click on the stop sign, see if you can solve this one. All right, this is called a net, and it's when a three-dimensional object is kind of unfolded and laid out to create a two-dimensional object. So here we have a square pyramid net. So if it got folded up, it would look like this square-based pyramid that we have right here. All right, click on the stop sign. Okay. Taking a look at this, we have some sort of a quadrilateral-based pyramid right here. And, okay, obviously G can't be it, because if we're looking straight down on G, it's a triangular-based pyramid. And let's see, J doesn't look like it can't be it. So it's either H or it's F. It's a little tricky, and the drawing here isn't the best, and actually it's been rotated. So if you looked at it like this, you would be able to see that F is the correct answer. What are the coordinates of point C? Click on the stop sign. All right. We know that x is 0, but in order for us to know that the y coordinate is 40, we had to recognize that each one of these marks here was worth 10. So we go 10, 20, 30, 40. X is 0, y is 40. Click on the stop sign. Okay, let's see how you did. If you got 30 degrees, great. Here we have a line that is the diameter, and it is 180 degrees, so this arc right here is 180 degrees. If we subtract 150 off of 180, that would leave us with 30 degrees left over. All right, these two lines S and R are parallel. See if you can determine what the and answer the question. All right, sorry about that. There was no stop sign. Anyway, so let's take a look at this. We have, it's asking of us if the angles 1 and 4 are supplementary, meaning that they total to 180 degrees. So angle 1 and 4 can't total to 180 degrees because both of them are way less than 90. These are called vertical angles, and they do not total to 180, but we do know that 1 and 4 are exactly equal to each other. S is 2 and 3. 2 and 3 are equal to each other. So this can't be right. Number 1 can't be right. If we look at 3 and 5, if these two lines are parallel, 3 plus 5 would be supplementary. And we'll take a look here. So we know that this can't be right. And so 3 plus 5. 3 plus 5 added together would be supplementary, so that's correct. And then it asks us if 1 and 6. So angle 1 and angle 6. 6 is the same thing as 2, so therefore 1 and 6 are supplementary. And then we take a look at 2 and 8. And so angle 2 and angle 8. 4 and 8 are the same, so 2 and 8 would be supplementary. So yes, that totals. So if we took a look at this, this would be the correct answer option here. All right, click on the stop sign, see if you can solve this. Well, works like this. The correct answer is going to be 30. We know that if this is 150 degrees right here, that this arc is also 150 degrees. The total circle is 360 degrees, which means that this arc right here happens to be 210. The difference between 210 and 150 is 60. Half of that is 30, and that gives us this angle measure right here. All right, triangle MNO is similar. That's what this little thing right here means they're similar to the triangle RST. And then it says find the length of RT. In other words, how long is that? Click on the stop sign, see if you can figure it out. Okay, we'll take a look. Well, if you got 12 centimeters, you're doing it right. There are multiple ways you could solve this. You could have set it up in a cross multiplication, and you could have said 4.5 centimeters over x. We don't know what x is, so 4.5 over this is similar to 3 over 8. And then you can cross multiply. So if I multiply 4.5 times 8, I get some answer, and x times 3 gives me the same answer. I solve for x, and I then take the answer that I get for x. I would then multiply times 8, and I would then get 12. So I also could have said, is there some number that multiplied times 3 will give me 4.5? And if you do that, you find out that x is equal to 1.5. And then if I multiply 3 times 1.5 to get me 4.5, then I multiply 8 times 1.5 to get 12. And everything's in centimeters, so that's the way that works. And by the way, 7 times 1.5 is the length of ST. All right, click on the stop sign, see how you do. Okay, well, if we take a look at any one of these points, if you can do 1 point, you'll be able to do them all. So if, let's say that I take D here, and it's important that you know your left from your right to be able to work this. So it says that I'm going to shift this, or translate this, 3 units to the left, 1, 2, 3. So my x value is going to be -2, and then I'm down 4, 1, 2, 3, 4. And so D prime would be right here at -2, -4. So if you got these answers right here, you're doing it right. All right, take a look at the picture. Do not assume it to be correct. Assume the information to be correct, and see if you can solve for x. Okay, let's see how you did. Well, the x is embedded into the a here. This is 3x plus 2. Most people have a little difficulty when they didn't see an x on the drawing here, other than this point right here. But that's a different x. So we know that a is 3x plus 2, and we know that b is equal to 22 degrees. Now what happens is, it told us in the words, not in the picture, that this is 90 degrees. Nowhere did it say that 3x plus 2 was equal to 22. So now what happens is, you have 3x plus 2 plus 22 equals 90. Group-like terms, solve for x, and you come up with x equals 22. All right, what is the degree measure of angle B? Click on the stop sign. Well, if you got 60, you're doing it right, because you recognize that this is a right triangle right here, and this right triangle right here, if this is 120, then its supplemental angle would be 60. So then you have this smaller triangle right here. If this is 60 and this is 90, this has to be 30. And if this is larger triangle, ACB, happens to be 90 degrees and 30 degrees, this has to be 60 here. So angle B has to be 60. All right, click on the stop sign and see if you can figure out how wide the house is. Okay, let's see how you did. Well, it works like this. If I drew a line right up here like this, that's the same width as the house. And if this is 120 degrees total, then this is 90 degrees here, which makes this 30 degrees here, which makes this a 30, 60, 90 triangle. And I know that the short leg is 9, and so if that's the case, I know that the hypotenuse is 18. And I also know, from it being one of our special right triangles, that 9 times square root 3 is the length of this side, and that comes out to about 15.5. Double 15.5 because that's only half of the width of the house, and I get 31 feet. If you'd carried the decimals out a little further, you might get slightly more than 31 feet, but if you have 31 feet, a couple of other numbers, you did it right. All right, click on the stop sign, see if you can solve for x. Turns out that x is equal to 30, because if you counted them, you have a total of 12 x's here, and it's 360 degrees all the way around. So 12x equals 360 degrees. Solve for x by dividing both sides by 12, and you get x equals 30 degrees. Find the area of the trapezoid. Click on the stop sign. All right, what you had to do here was you had to find the length of this. And the way you can find the length of that is if you drop a perpendicular right here like this, you might recognize that this is a 45, 45, 90, or one of our special right triangles. You know that this is going to be 7 in length, and that means this has to be 7 in length. And 14 minus 7 means that this is 7 in length. And so 7 times 7 is 49, which makes this 49 units squared. And 7 times 7 divided by 2 is 24.5 units squared. Add those together, and you come up with 73.5 units squared. All right, find the length of L to the nearest tenth. Click on the stop sign. Okay, let's see how you did. Well, if this is a 30, 60, 90 triangle, then this happens to be 2 times x, or 2 times 7, which means that it is 14 units long. Now we have a larger triangle right here, right triangle, that has a hypotenuse of 14 and a leg of 11.5. Using the Pythagorean theorem, or a different version of that, we can rewrite 14 as equal to the square root of 196, and we can rewrite 11.5 as the square root of 132.25. Subtracting 132.25, the number, from the number 196, we wind up with 63.75, and taking the square root of that, we get 7.98. But the question was to the nearest tenth. which means that the answer becomes 8. And not only does it become 8, but I've messed up a little bit here when I was still setting this up, is actually the correct answer would be 8.0, because that's the nearest tenth. All right, find the length of the hypotenuse. Click on the stop sign. Well, you don't know how long m is, and you don't know how long L is, but you could, using the Pythagorean theorem, replace m with an a, or replace the a in the Pythagorean theorem, excuse me, with an m, and the b in the Pythagorean theorem with the L, and you could come up with that the length of the hypotenuse here is the square root of m squared plus L squared. So it's just a different variation of the Pythagorean theorem of a squared plus b squared equals c squared. All right, you have a giant shoebox. It measures so much. Find its total surface area. Click on the stop sign. Okay, let's see how you did. Well, it works like this. The quick sketch that I made has the shoebox being 1 foot in this direction right here, and 2 feet in this direction right here, and 3 feet in this direction right here, and I'm dealing with just 6 rectangles. So 1 times 3 is 3 units squared. This side of the rectangle, or the shoebox, is 2 times 3, it's 6 units squared, and this one happens to be 2 times 1, which is 2 units squared. Add those together, and I have the total surface area of half of the box. So multiply that times 2, and I get 22 units squared. Okay, now find the volume of a shoebox with similar, but find the volume of a shoebox with slightly different dimensions. First thing that I did was I drew a picture, and so the tricky part here was that one of these was in decimals, one of them didn't have decimals or fractions connected to it, and the other one was in fractions. So I converted this 1/4, 2 1/4 to 0.25. Then I simply looked at what's the formula for finding the volume of something like this? Well, it's big B times H. Big B just means find the area of, and the area of the base on this is just length times width of one of the rectangles times the height. So if you did all of that, you would have come up with 10.125 units cubed. Cubed is the way that we denote that it was volume. All right, click on the stop sign, see how you do. Well, you have a side of a square that's measured 7.2 inches, so I just drew a picture, and now I have a square that's 7.2 by 7.2, and it says the lengths are quadrupled. So 7.2 times 4 is 28.8. Now it's a square, so I just multiplied 28.8 times 28.8, and I got 829.44 units squared. What's being shown here? Click on the stop sign. Well, this is a compass construction, and what's being shown here is that we're copying an angle. All right, we have an arc that is 100 degrees. What is the measure of angle M? Click on the stop sign. Okay, let's see how you did. Well, turns out that the correct answer is 50 degrees. How did we get that? Well, this arc right here is 100 degrees. And this angle, not being a central angle, but terminating, the vertex being on the far side, this is 1/2 of whatever the angle is. And so if this arc was 100 degrees, then that means this angle M right here is going to be 50 degrees. Okay, now here we have an arc, BOY. It's 200 degrees. What is the measure of angle O? All right, works like this. We know that arc BOY is 200 degrees, so that means this right here is 200 degrees, and all the way around is 360, so that means this arc right here happens to be 160 degrees, and angle O would be half of 160, or exactly 80 degrees. All right, click on the stop sign, see if you can solve for the measure of angle V. Well, it turns out that the measure of angle V is 45 degrees. How did we get that? Well, the way you find when you have, in this case, a tangent line and a secant line that come together on the outside of the circle, this angle right here, angle V, is going to be half the difference between these two. So if I take 120 and I subtract 30 from that, I'm given 90 degrees. That's the difference between the two, and I take half of that, and that's my angle V. So angle V is 45 degrees. All right, this is a central angle, so click on the stop sign, see if you can answer the question. Correct answer is 40 degrees. How did we get that? Well, we are told that the distance from ACB is 320 degrees. Subtract 320 from 360, and we are left with 40 degrees because the central angle and the arc are the same thing. This being a central angle here on circle M, we know it's circle M because the center point is labeled M. All right, find the total area of the figure above. Click on the stop sign. Okay, let's see how you did. Well, you could have recognized that you needed to break this up into two parts. Here we have a rectangle. We know that this length is 12, but we don't know what this length here is. And we notice that we have a 45, 90, 45 angle right here. And if this is 2 and that is 2, we know that they're the same because these lines show that they are the same. So that means that this length right here minus 4 is going to give us this length right here. And if we did that, we would find that this length right here is going to, that length right here is going to be 10 times the square root of 2, or 14.14, corrected 2 decimal places. Subtract 4 from that. We're subtracting 2 here, and we're subtracting 2 here, which means that this now becomes 10.14, which means that this area right here is 121.68 units squared, and our the pointy part of our arrow here is just a right triangle. And we know that the length times the width divided by 2 is going to give us the area of the triangle. And, excuse me, it's base times height times 2. Excuse me, it's base times height divided by 2. So 10 times 10 divided by 2 is going to be 50. Add all those together, and we get 171.68 units squared. So the total of these area of this arrow is 171.68 units squared. Your comments, questions, and suggestions are welcome, encouraged, and appreciated. You may write to me at alanmorris@yahoo.com.